Greetings and welcome to our 9th devlog. I am Mark, and in this iteration we'll show you our complete stealth system with line of sight, noise making and noise detection, working together with our chasing state, and now our new escaping state. All of this coming up next. Being honest, with the scopes of the devlog, contemplating almost entirely programming goals, we started the week a little more worried than excited. Particularly when the objective relies so much on an intelligent system as fickle as the nav mesh, which seems to wake up in a worse mood every day. You have no idea how many pigs I've slaughtered in these simulations, only to find or recreate a bug in our code. Although truly, the thugs end up killing more their allies than the pigs with friendly fire, which we could remove, but where would be the justice? It took a lot of trial and error to finally come up with a system that will leave us satisfied, and despite our less than ideal programming skills, slow progress, and constant setbacks to investigate and solve weird bugs, we are quite proud of the results. But if you have any advices or suggestions that you want us to consider, please put them in the comment section below. Any feedback is awesome, especially in these stages of the project. And in case you want to see how we integrate everything into our tutorial quests, please consider liking and subscribing, because if things continue as they've been, soon we might be able to upload a build for you guys to playtest. But anyway, returning to the stealth system, in a summarized way, it works as follows. Mainly, we have two parts. First, there is the detection system, and then there are the behaviors integrated into our state machine that vary depending on the information provided by the first part. In the detection system, we have the line of sight, which we briefly explained last week, and have refined based on the bugs found so far. As in the last week, in start, we make a list of all the creatures with attacks we've selected so far, but we only add those we detected as alive. For now, we're using attack for the player, attack for the thugs, and attack for the livestock, but we can add as many tags as we need later. Then we deduce if we can see them using a filter system. First, it calculates which targets are within our range of vision. After that, we check if they fall within our cone of vision as well, and if they do, then we use a raycast to check if there are obstacles blocking them from our view. Finally, we check if they are alive, and if they are not, we permanently remove them from our search list. This way we can also avoid them in further calculations. But if they are alive, then the boolean returns true, our angle of vision becomes of 360 degrees to avoid blind spots during combat, and we save in a new list all the creatures we get on sight. When there are no longer any creatures in this new list, using the 360 degree angle of vision, then we return to the smaller cone of vision and the boolean returns false. This is our most expensive process. It is not ideal because it only stores the highest object in the look for list, but we left it like that because this makes it a lot more efficient and the results in the simulations are acceptable within our scopes. But as always, any corrections or suggestions in the comments will be greatly appreciated. And finally, among the objects on site, we can access and return the closest to us to give priority based on proximity. Although, as we discussed, currently it only takes into account the highest on the list. Now it is much more efficient, and it also updates based on whether we see any of the creatures we're looking for dead. And it also expands if any unknown creature infringes harm on us, so that the NPCs can counterattack or flee from the new threat. These changes are also stored in our saving system, so your actions and decisions will not be easily forgotten. New, we have the noise system that is quite simple. The code that makes the noise only triggers a coroutine that activates and deactivates a moment later a collider, basing its size on the value sent to its public method. This way we can make noise from anywhere with an event of our choosing. Right now we trigger it with animation events, so that each step of the thugs generates sound, In the future, we want to use it with distractions thrown by our player or any other tools we can come up to. And the noise detection code only detects if it's within the area of this collider. If so, it compares the tag of the object that made the sound with its own to make sure as to not to detect itself or its allies, and if there are different tags, it triggers an event that passes the location of the origin of the sound. The objects that produce the noise and those that detect it are in an isolated layer, so that they shouldn't interfere with any triggers outside this logic. And now our reaction will depend entirely on three factors. First, of course, is which detection system we add to each NPC, and also which tags we add to the line of sight. If we do not have the tags of the creatures in front of us, we simply will not react by sight, and if we do not have the noise detection, we will not react to their footsteps or the distractions thrown by the player either. But assuming we have the tags and the noise detection, then we depend on whether or not our NPC is aggressive. If it detects a noise and is not aggressive, it will turn in the direction of the source of the noise to check if it can see anything, and if not, after a few seconds, it will return to its patrol route or normal behavior. If it detects a noise and is aggressive, then it will also turn to the origin of the sound, but now it will also add the origin to its patrol route as the next destination, so that after waiting for a moment, it will investigate the area, wait for a moment there looking around, and if it can't find anything, then it will return to its normal route or normal behavior. And of course, the reactions based on the line of sight also depends on whether or not we are aggressive, and of course whether or not we are looking for these creatures. It should be added that we can also control aggressiveness and look force from external code such as Devlog, an important resource if we want to make social interactions more interesting, either by making enemies or why not also by making allies. But anyway, if we're not aggressive and we see one of these creatures, we're going to consider them as a threat and enter the escaping state. This state and the chasing state are quite similar, but this one is much more complex. At the beginning, we check for threats. If we detect one, then we save its position and the direction it comes from, and then we indicate a desired escape destination based on the opposite direction multiplied by a specific distance. This presents the first inconvenience. What if that route ends behind a fence and you have to go around a very long distance just to reach it, or if it's located on an island of nav mesh that does not connect with the nav mesh you're standing on? Well, for that we have to create a method to validate our escape routes that checks for us if it's possible to create a route in the desired destination, if the final waypoint of this route is reachable, and also if the distance to reach this final waypoint is less than the desired distance, which in this case we indicated as 30 meters. If this criteria is not met, then we have to create an alternate route based on the same desired distance, which in this case is of 5 meters, but now multiplied by a random direction that leads us to choose between turning left or turning right. If in Unity the forward direction is 0 degrees, the right is 90 degrees, turning back is 180, and turning left is 270 degrees, we need a random range that results in options close to 90 and 270, ideally moving away from getting 180, because that would mean running directly towards the threat. We got it working using a random range from 50 to 310, but using two clamps depending on whether the result is greater or less than 180 degrees, and limiting the result from 50 to 130 or from 230 to 310, 80 degrees of range for each side. This way we created a surprisingly functional fleeing logic. When we reach the calculated destination, we check again for threats. If there are any, we continue looking for escaping routes, or if there are not, we return to idle. And now we can see this in action with our simulations. In this one, only the peaks detect noise, and the visual obstacles work for both. So if they hear something, they turn to look for threats, and when they get a direct line of sight to the thugs, then they start to flee. We lack the animations for the peaks, but if they die, they turn red to make it easier to see. Of course, with friendly fire, many of the thugs get killed, which we can change depending on the enemy, perhaps with a group of wolves, which we want to introduce later. I would remove the damage to allies, but we will decide these details later. If we remove the thugs from the attack list of the peaks and give them more health points, they will not start fleeing until they are hit and now consider the thugs a threat. And if instead we make them aggressive, then once they get damage, they will attack back to kill the thugs. I have planned many interactions of our game based on these behaviors, and I want to see how everything continues to develop. But for now, this will be all for the moment. For the following week, in addition to adding the chickens, we also want to introduce the animations for these and the pigs, variations of textures for both, a state that allows us to pick them up to take them to their pen, and see if we can also create the quest that integrates everything, at least at a basic level, for testing. Thank you very much for your consideration and for staying with us until the end of the video. If you're interested in the project, also consider joining us on Twitch, Tuesdays and Thursdays, where you can appreciate our suffering in real time, mainly in Spanish, but I will also appreciate the opportunity to practice my English. Links to this in the description of the video. I am Mac from Tryhard Studio. Until next week, and finally just to wish you as always a lot of success in your projects, and see you soon.